This is class 28 of my arithmetic course. Today we're going to learn basic statistics and graphs. If you haven't done the homework from class 27, do that homework completely and correctly before watching this video. First, let's talk about what statistics is. Statistics is the study of lists of numbers. For example, you might record the weights of 100 tomatoes from a particular garden, and you'll study that list of numbers. You might record the selling prices of houses in a particular city and study those numbers. So those are some examples of lists of numbers that we could study. Lists of numbers are also called data sets. Here we have example data set number 1. These numbers here are the data set. They represent masses of common candy bars in grams. In this class, we're going to calculate these values for every data set. These 6 values. These 6 values are the most useful values that we calculate in a particular data set. But just be aware before we go forward that statistics is really only useful if you have large data sets. Hundreds and hundreds of numbers, maybe even thousands or maybe even millions of numbers. But the data sets we're going to use in this class are fairly small, simply because it would take too long to perform calculations with large data sets, so we're going to use small data sets. But again, just be aware that statistics is really pretty useless with small data sets. The numbers are only meaningful if you're dealing with hundreds or thousands of numbers. I want you to take a screenshot of these definitions. I want you to take a screenshot of all this stuff, because we're going to use that in every data set in this class. Why do we care about these definitions? Well, these first 3 definitions are what they call measures of center. They measure the center of the data. So if you order these numbers from least to greatest, these values would give you some sort of an approximation of the center of the data. Now you're probably thinking, why do we care about the center of the data? Well, the reason we care is that in many cases, not all cases, the center of the data represents a typical value. For example, notice the mean here is also called the average. Mathematicians call the average the mean. There's actually a lot of different types of means. For example, there's the arithmetic mean, which is what we're going to use in this class. Whenever you hear the word mean, we're talking about the arithmetic mean, but there's actually a lot of different types of means. Mathematicians, they use the word mean, but in the real world, they don't use the word mean. They use the word average. So just be aware of that. But you might hear somebody say that the average weight of a cat is 8 pounds, which is true. That's about the average weight of cats. Or you might say that's an average height of a tree. Or you might say that car is not a very good car. It's not a bad car. It's kind of just an average performing car. Average means just a typical thing, has typical characteristics. So when the center of the data oftentimes represents a typical example of something. So that's why we care about the center of the data. Now these values range, and the quartiles and the interquartile range, they measure how spread out the data is. So here the smallest value is 21, the biggest value is 51. So we subtract those 2 numbers to get 30, and 30 is the range of the data. So it just measures how spread out the data is. And an outlier, that's just a number that's unusually big or unusually small. For example, in this data set, if I add a number over here, let's say I add the number 2, well, that number is very, very small compared to all these other numbers. So this number would be considered an outlier. So that's what an outlier is. So as we learn to study, and again, these 3 centers of mean, they're just different ways of recording the center. Sometimes this center works, this definition works the best. Sometimes this definition works the best. You're going to learn more and more about this stuff as you go into advanced mathematics. But for now, we're just going to learn how to calculate these numbers. We're not going to go into a huge explanation, but one of the most important things that I want to say about statistics, and that I think I touched on earlier, is that statistics doesn't work in every data set. There are some data sets where these statistical numbers are completely useless. So you need to be aware that sometimes statistics works, sometimes it doesn't. And you'll find when you get older and you start to study politics and whatnot, you'll find that statistics is actually used to deceive people. So you have to be very careful about statistics. It can be used for good or it can be used for evil. So anyway, that said, let's go ahead and start calculating these values. So we're going to study this data set. We're going to study this list of numbers. So first, let's calculate the mean. The mean is the sum of all these numbers divided by the number of the numbers. So what that means is there's 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to add up all these numbers and divide by 7. So actually, I'm going to copy this data set, and I'm going to bring it down here so I don't have to keep scrolling up there. All right, so we're going to add up all the numbers and divide by 7. So the mean is equal to 40 plus 43 plus 38 plus 21 plus 43 plus 51 plus 42 divided by 7. So that's all we have to do to find the mean. Now notice that I put the parentheses. Remember the class on order of operations? The reason that I put the parentheses is because order of operations tells us to divide first, then add. But to find the mean, mathematicians want you not to divide first, they want you to add first. So I have to violate the order of operations and I have to put these parentheses. So this is just ways to communicate with other mathematicians. That's all that is. So let's go ahead and add those up. That's a lot of numbers, so we're going to have to line them up vertically like we learned in previous classes. All right, so we're going to add up all these numbers in the ones place. And I get 18. Carry the 1 up here. And I got 27, 278. Let me just double check those numbers. That looks right. So now we have to take 278, so let's write that. 278 divided by 7. And we have to find 278 divided by 7. So in order to do that, we have to use the long division algorithm. You can do it in your head, but that wouldn't be easy. So 7 does not go into 2, but it does go into 27. It goes 3 times. Notice the 3 goes up on top of the last number that we divided into, the last digit of the number we divided into. 7 times 3 is 21. 27 minus 21 is 6. And bring down the next number. 7 goes into 68. 9 times. 7 times 9 is 63. Subtract. You get 5. Bring down a 0. 7 goes into 57 times. 7 times 7 is 49. And we have a remainder 1. Bring down a 0. 7 goes in 1 time. Remainder 3. All this long division stuff is review for you. 28, 2. And as you can see, because we're dividing by 7, we're just going to keep going on and on and on. It's never going to stop. So what we're going to have to do is round off. So the decimal was here, right? The decimal is right there. So because the divisor is a whole number, we don't have to move a decimal over to get to this line. And we don't have to move this decimal over. We just bring it straight up. So we got 39.7142, and we're just going to round off to the nearest hundredth place. So I'm going to shrink this because we don't run out of room here. So that would be 39.71. That's the mean. So that would be the center of the data. Usually that would be a fairly good predictor of a typical value of the data. So a typical value for the mass of a candy bar would be 39.7142. That's a good predictor. Or excuse me, 39.71 if we round off to the nearest hundredth place. Now you always have to put your units. So our units are grams, so we're going to put G for grams. Now again, sometimes that number makes sense, sometimes it's useful, sometimes it's not. So now we're going to, let's section off that work. Now we're going to find the median. We found the mean. Now we're going to find the median. The median is just another way of measuring the center. The good thing about the median is it's not influenced by outliers, because the median is just the middle number. So the most important thing to understand about the median is that we cannot find it unless we first order the numbers from least to greatest. So I'm going to do that up here to save room. So 21 is the smallest number. Then 38 is the next biggest. Then I believe 40 is the next biggest. Then 42. Then we have two 43s. And then we have a 51. I believe that's all of those. Let me shrink that. 1, 2, 3, 4, 5, 6, 7. That's all the numbers. So we ordered the numbers from least to greatest up here. And now the median is defined. You ready for this? This is what the median is. The median is defined as the middle number. So here's what you do. A lot of students like to block off pairs of numbers at the end. So you block off those pairs, you block off these pairs, you block off these pairs, and then there you go. That's the middle. 42 is the middle number. So the median is 42, and we have to put grams. So 42 is another estimate of the center of the data. Notice that the median was not exactly the same as the, let's see here, let me get a different color. Median was not exactly the same as the mean, but they're still representative of the center of the data. They would be good examples of a typical candy bar mass. So again, these numbers are not tremendously useful because our data set is so small. If we had a huge data set, those numbers would be much more meaningful. So now we're going to find the mode. Now there's good news with the mode. The mode is really easy to find. The mode is just the number that appears the most in the data set. So look at your data set. Which number appears the most? Well, 43 appears the most. It appears 2 times, whereas the other numbers only appear once each. So the mode, the reason that the mode is considered a representative of the center of the data is because the number that appears the most oftentimes is the number that is in the middle of the data. For example, the average weight of a cat. If you measure the weight of all the cats in the world, most of them are going to be about 8 pounds. In fact, the weight of the cats, the most common weight is going to be 8 pounds. So that's going to be the mode. That's going to be the center of the data. All the other weights are going to be around that weight. So that's why mode is considered a center. Now you notice in this example, the mode was 43. That may or may not be a good representation of this data. It seems like it might be a fairly good representation, but again, it just depends on the data set. All right, so we're going to put grams on that. Can't forget to put the units. So those are the 3 measures of the center of the data. Now we're going to measure how spread out the data is. To do that, we first find range. Now again, look at your screenshot, bring up your screenshot to find the definitions of these things, and if you're reading the definition, you already know what to do. The range is just the biggest number minus the smallest number. So if we do that, 51 minus 21, 1 minus 1 is 0, 5 minus 2 is 3. That's 30 grams. So that's the range of the data set. And we should probably put our subtraction sign there. Whoops. All right, so that shows our work there that we did. for the range. All right, so that just tells us how spread out the data is. If we had a much bigger value, a much bigger maximum value, say we had 100 instead of 51, or say we had only, say, 5 as the smallest value instead of 21, the range would be much bigger. The data, the numbers would be much more spread out. So the range measures how spread out the data is. All right, so now we're going to find the interquartile range. But before we do that, we have to find the first and third quartile. So to find let's first find the first quartile. Quartile means quarter. It means a fourth of the data. So what you're doing is you're breaking the data into 4 parts, and you're finding the first quartile and the third quartile. I know that sounds esoteric there, but here's how we find it. We divide all the data into 2 halves. We're going to, in this case, we have an odd number of numbers, and all that means, we haven't talked about even and odd numbers, but odd numbers are 1, 3, 5, 7, and even numbers are between those 2, 4, 6, and 8. So the best definition of an even number is it's divisible by 2. The odd numbers are not divisible by 2. So we have 7 numbers. 7 is an odd number. So this is an odd number of numbers in our data set. So when you have an odd number of numbers, you just take the middle number and you ignore it. So we're just going to ignore 42 and consider this to be the first half of the data, and this is going to be the second half of the data. Now, the first quartile is defined as the median of the first half of the data. Now, I know that sounds really complicated, but it's really not complicated at all. And keep in mind, after we do this last part, we're done. That's all the stuff that we have to find for these data sets, other than we're going to do some quick graphing at the end. But this is everything you have to do for these problems. And we're just going to do those things over and over and over again for data sets until you get used to finding these values. So I know it's getting kind of complicated here, but just bear with me. So we're going to find the median of the first half of the data, this first half. Now remember, the median is just the middle number. So you can see the median, when you order the numbers from least to greatest, is just 38. That's the middle of the first half of the data. So Q1 is 38 grams. And we notate the first quartile as Q1. I don't think I mentioned that. Q3 is the middle of the second half of the data. So as you can see, the middle of the second half is 43. So Q3 is 43 grams. Q3 is 43 grams. All right, I guess we can rectangle those. So now you're probably wondering, well, why did we find why did we find those numbers? Well, we found those numbers so we could calculate the interquartile range. I know that's a fancy word. The interquartile range is Q3 minus Q1, and I'm going to explain what this means after we calculate it. So that's 43 minus 38, and go ahead and do that over here if you want. We're going to subtract. We cannot subtract 8 from 3, so we have to borrow from the 4. It becomes 3. Give the 1 you borrow from 4 to the 3, and it becomes 13. 13 minus 8 is 5. 3 minus 3 is 0. So 43 minus 38 is 5, and we're going to put grams. So the interquartile range is 5 grams. So notice that the interquartile range, again, these are interquartile range and the range are both measures of how spread out the data is. It's extremely important to note that the interquartile range is much smaller than the normal range. So the interquartile range takes the middle part of the data, it kind of cuts the data, it cuts the middle part of the data out, and it finds that range of that middle part. And the reason the interquartile range is important is because it gets rid of outliers. For example, if you had an outlier of, say, over here you had 100 grams, the interquartile range takes the range of the middle numbers and it ignores this outlier. So that's why the interquartile range is valuable, because sometimes outliers, we can just ignore them, because if there's a candy bar that's 100 grams, that's so unusual that we may not even care about that number. We'll just discard it. Maybe that number is just something the candy factories made to put in some display case or something. It wasn't really meant to eat, so we don't care about that candy bar, because that candy bar is just for show. All right, so that's the interquartile range. So now we're going to do one more thing here. We're going to graph the data. The best way to understand the data is to graph it, because when you graph the data, you can see a complete distribution of the data. Now, the word distribution is just a fancy word for how the data is spread out and where the center of the data is. So let's go ahead and do that. So to make the graph, we have to start with the smallest value, or something near the smallest value. I'll start with 20. And it's important to understand that you set the scale for this graph. Okay, you are going to set the scale yourself. You have to determine that yourself. So you might try a certain scale. I'm going to try going up by 5s. And it looks like that's going to work. I think I'm going to have to move that over a little bit. So going up, starting at 20 and going up by 5s all the way to 55, it looks like that's going to work. But if your scale doesn't look like it's going to make sense, if the scale makes the graph too small, or if it makes it too big, then obviously you have to redo the scale. That's up to you to figure that out. So what we're going to do is we're going to make a graph called a dot plot. Okay, it's called a dot plot. So what we're going to do is we're going to write dots for the numbers. We have 21, and I'm looking at the list up here. We have 38, 40, 42, 43, another 43. So we have two 43s. So what you have to do is you have to write two dots on top of each other. You see that? Because there's two 43s. Then we're going to write a 51 over here. And that's the dot plot. Very simple. So again, you're probably thinking, well, why did we do that? What was the point of that? Well, again, you can see the distribution. This is the easiest way to see the distribution of the data. We can see how spread out it is. We can see what the typical values are. This is the center over here. That's a cluster of data. So most of the candy bars are somewhere over here, and these numbers are actually seem to be outliers. We can see how spread out the data is. We can see the center. So it's just an easy way to see the distribution of the data, which is, again, is just a fancy way of saying the spread and the center of the data. But there's an even more sophisticated way to look at the data. We're going to use some of the numbers that we calculated to make what's called, again, this is called a dot plot. That's what that's called. Not to be confused with a dot graph. A dot graph is something different. The words in statistics can kind of be confusing. So a dot graph is not the same thing as a dot plot. So we're going to do something called above this dot plot, we're going to do something called a box and whisker plot. So what we're going to do, there's going to be 5 numbers that we're going to graph here. We're going to put a vertical line on the smallest number here. We're going to put a vertical line on the biggest number here. We're then going to put, and by the way, these dots don't have to be exact. Don't waste a lot of time trying to get out a ruler and trying to make everything perfect. And these lines don't have to be perfect. This is not an art class. Don't waste time trying to make everything perfect. Just make it to where it makes sense. So now what we're going to do is we're going to make a vertical line at the median, which is 42. That's, let's see, that's this value here, I believe. And then we're going to make two other vertical lines at the first and third quartile. The first quartile is 38. That's here. And I'm just doing these lines right above the dots. The third quartile is at, what was the third quartile? Third quartile was 43. So that's going to be right here. So then those are the 5 numbers that you need to make a box and whisker plot, the 5 vertical lines. Then you're going to make a box with the middle 3 lines, and you're going to make whiskers with the other 2 lines. So that's a box and whisker plot, which we graph with the median and the first and third quartile and the biggest and smallest values. So again, you're probably wondering, why in the world did we draw this weird looking thing? And by the way, you can consider this to be like the face of a cat. We already mentioned cats today. That's the face of a cat, and these are the whiskers of a cat. That's kind of a way to think about it. But instead of a cat with whiskers, we have a box with whiskers. So you're probably thinking, well, why in the world did we draw this weird looking thing? Well, it shows us the distribution. It shows us where most of the data is. Notice this box is where most of the data is. It shows us where the very center of the data is, the median, or where we estimate it to be. And then it shows us the range, the full range of the data. So we have the interquartile range, which is Q3 minus Q1, where most of the data is, and we have the total range. So this kind of demonstrates why the interquartile range is important, is because the interquartile range just ignores these outliers. So if we don't care about these weird outlier numbers, we can just say, well, let's just forget that and calculate the interquartile range, and that will be a range representative of most of the numbers. So I know this seems like a lot of sophisticated stuff, but in this class today, all we're going to do is calculate these same numbers for a bunch of different data sets, and that's pretty much the class. We are going to do some bar graphs and some line graphs at the end of this class, but that's going to go pretty quickly. But that's all we're going to do. We're just going to calculate these numbers for a bunch of different data sets, and then we're going to do some bar graphs and line graphs really quickly at the end, and then we'll be done. So I know this stuff seems complicated, but that's really all we're going to do today. So now let's do another example data set. Now we're talking about the horsepower of small displacement sport motorcycles. So horsepower is just how powerful the engine is. Now again, if you didn't take a screenshot of these numbers, you got to keep referring back to these definitions. A screenshot of these definitions. So if you didn't do that already, take a screenshot of all this and you want to refer back to that. All right, so now we're going to calculate those numbers for this new data set. So first, let's calculate the mean. The mean is equal to the sum of the numbers divided by how many numbers there are. There's 1, 2, 3, 4, 5, 6 numbers. So we divide by 6. So first we have to add all those numbers up. So in order to do that, we have to line them up vertically. And whenever you add or subtract decimals, you have to line up the decimal. Remember that? If you don't line up the decimal, you're guaranteed to get it wrong. Now, if you put the 31 here, you're going to get the wrong answer. The 31 goes here, and the decimal is directly to the right of the number in the ones place, which is happens to be 1. We can put a 0 there for a placeholder. These are little things that you've got to watch out for, or else you're going to get the wrong answer. All right, so that's all those numbers. Let's add everything up. Actually, we should double check, make sure we got all those numbers written correctly. I think that's correct. All right, add the numbers up. We get 22, carry the 2. We get 19, carry the 1. So we got 19. So now we have 199.2 divided by 6. So we have to use the long division algorithm. We could do that in our head, but it's a lot easier to use the long division algorithm. Bring the decimal straight up, and we have exactly 33.2 HP. HP stands for horsepower. So that's the mean horsepower. That should represent a typical number for the power of an engine, and in this case it does to a certain extent. It represents the center of the data. So now we're going to find the median. The median is the middle of the data, and the important thing to understand is we cannot find the median unless we first order the numbers from least to greatest. All right, so those are the numbers ordered from least to greatest. Let me just double check all those numbers. I think I got those right. So now we can use that method of blocking out the numbers in pairs to find the middle numbers. But as you can see, something weird is going to happen. There is no middle number. If you block out these two, there's no number left. There's no middle number. And the reason there's no middle number is that this data set has an even number of numbers. There's 6 numbers. 6 is even. So when you're trying to find the median of a data set that has an even number of numbers, there is no middle number. So what we're going to do is we're going to take these two numbers and we're going to find the number that's right between them. Even though the number right between them isn't a number in the data set, that number is going to be the median. So again, the median is literally the center of the data. So what we're going to do, and this is the definition, this is how we do this, we're going to use the mean, the definition of mean, to find the number between these two values. It turns out when you find the mean of two numbers, that number ends up being exactly in between, exactly halfway between these two numbers. So the median is going to be the mean of those two numbers. So that's going to be, and remember, to find the mean, you add up the two numbers and you divide by how many numbers there are. Well, this time, for these two numbers, there's only 2 numbers. So divide by 2. Add them up, and you get 66.1. So we have 66.1 divided by 2, and I'm going to go up here to do the long division. 66.1 divided by 2. 2 goes into 6 3 times. Bring down the 6, goes in 3 times again. Bring down the 1, and 2 doesn't go in. After you bring down the 1, it doesn't go in. So you have to, because the 2 doesn't go into the 1, after you bring it down, you have to put a 0 up here. And then you have to bring down another number. So we have 2 into 10 goes 5 times. So be very careful about that 0 there. We brought down the 1, and after we brought down the 1, the 2 still didn't go in, so we had to put a 0. A lot of students will trip up on that. So then we brought down another 0 here, and 2 into 10 goes 5 times. So then we bring the decimal straight up. Then we got 33.05. And we have to put horsepower, HP. I can't forget to do that. All right, so let's section off that work. So again, it was different when we had an even number of numbers. You had to find the mean of these two numbers. All right, so notice that the median is not exactly the same as the mean, but in this case, it's almost exactly the same, pretty close. Again, these are numbers that are measures of the center. All right, so now we have to find the mode. The mode is the number that appears the most. But as you can see, there is no number that appears multiple times. So in this case, there is no mode. We can just put none. No mode. All right, now we have to find the range. The range is equal to the biggest value, which is 43.3, minus the smallest value, which is 20.6. So we can do that over here. 43.3 minus 20.6. Remember to line up the decimal. We can't subtract 6 from 3. Sorry, this is kind of small. So we borrow from this 3, it becomes a 2, give to that 3, becomes 13. We got 7, 2 minus 0 is 2, 4 minus 2 is 2, bring the decimal straight down. 22.7 horsepower. That is the range of the data. All right, so now we have to calculate the interquartile range, and I'm going to have to shrink all this stuff because we're running out of room. All right, so the interquartile range, we have to find quartile 1 and quartile 3 to find the interquartile range. So quartile 1 is the middle of the first half of the data. This is the first half of the data. And this is the second half of the data. Now notice in the previous example, when we divided the data in halves, when we had an odd number of numbers, 7, the middle number we just discarded. We didn't care about that. But now that we have an even number of numbers, 6 numbers, we don't discard the middle number because there is no middle number. So this is the first half and this is the second half of the data. So the first quartile is the median of the first half of the data. The median is just the middle number. So the middle number is 26.7. So quartile 1 is 26.7. So finding the first quartile was really easy on that one. Now we find the median of the second half of the data, which is the middle number of the second half, which is 42.5. So Q3 is 42.5 horsepower. So now we use those two numbers to find the interquartile range, which we abbreviate IQR. And interquartile range is the third quartile minus the first quartile. And I'm going to go ahead and do that in my head because we don't have time to do the math on that. I think that's 15.8, if I got that correct. I'm going to do that on my calculator just to make sure. 42.5 minus 26.7, 15.8 horsepower. That's the interquartile range. Notice that the interquartile range is smaller than the overall range. It's supposed to be smaller. All right, so we have the interquartile range, and we're pretty much done with all those numbers that we're calculating. Rectangling all the answers there. Now we just have to make a dot plot and a box and whisker plot to show the distribution of the data. So we can look at our numbers up here. We can see the smallest number is 20.6 and the biggest number is 43.3. So we have to figure out an appropriate scale. I think if we go up by 5s, that should be good enough. So we'll start at 20 and then 25, 30, 35, 40, and 45. Yep, that's big enough. All right, now we make, if that's annoying you because it's too far to the right, I'll move that over there. So now we do our dots. So 20.6, 26.7, 31, 35.1, 42.5, 43.3. Those are all our dots. All right, so that's the distribution of the data. We can see the spread. We can see where the center is. This is the spread. It's from here to here. We can see where the center is. It's somewhere around here. So this, again, showing the distribution of the data is very useful. It's an easy way for us to see what's going on with this data. Now we're going to use a different way to find the spread. We're going to use that box and whisker plot. Again, this is called a dot plot. We're going to use a box and whisker plot. So we're going to do a vertical line on the smallest value, a vertical line on the biggest value. We're going to do a vertical line on the median. The median is 33.05. 33.05 would be about there. Again, doesn't have to be exact. And we need a vertical line with wait a second, that should be a little bit over there. We're going to do a vertical line at Q1, which is 26.7, which is exactly on top of this dot. And Q3 is exactly on top of this dot, I believe. Yeah. So then we're going to draw a box with the inner 3 lines, and then we're going to draw the whiskers with the outer 2 lines. And that's your box and whisker plot. It shows that most of the data is in this interquartile range, but there are some data points out here. And it shows the center of the data as the median. So the box and whisker plot is just another way to show the distribution of the data. So now we're going to move on to some problems for you to do. So we're going to take this step by step. You should have these values. You should have a screenshot of these values to refer to. So we're going to study the wingspans of harpy eagles. Harpy eagles are very large eagles that are so large they actually take sloths out of trees. They're very large eagles. We're going to measure the wingspan. If you take the eagle and spread out its wings and measure from the very tip of the left wing to the tip of the right wing, that's the wingspan of the eagle. So our instructions here are to, and we're only measuring 5 wingspans here, so we only measured 5 eagles. And our instructions are to find the mean, median, mode, range, and interquartile range. Then we're going to make a dot plot, just like we did here, and a box and whisker plot, just like we did here. So we're basically just doing the same thing we did for the first 2 data sets. All right, so first we're going to find the mean. So why don't you go ahead and find the mean, and when you come back, we'll do it together. All right, we're back. So the mean is equal to the sum of the data divided by the number of numbers in the data. there's 1, 2, 3, 4, 5 numbers. So we divide by 5. All right, so we're going to go ahead and add those numbers up. So I got 960. Then we have to divide 960 by 5. So we're going to use the long division algorithm for that. So we get 192. So 192 centimeters is the average or the mean wingspan of these Harpy eagles. You can also call it the average. So that represents a typical wingspan for these eagles. So if you got 192 centimeters, good job. So now we're going to find the median. So to find the median, you must order the numbers from least to greatest, then find the middle number. So we have an odd number of numbers. 5 is an odd number of numbers. 1, 2, 3, 4, 5. So in this case, there is going to be a middle number. We're not going to have to do any fancy mathematics to find the middle number. So order those numbers from least to greatest and find the middle number. When you come back, we'll do it together. All right, we're back. So we're going to order those numbers from least to greatest. And now we're going to find the middle number. We can use our pair method to block out these pairs. And then after blocking out 2 pairs, you can see the middle number is 191. So the median was really easy to find in this case, 191. But you have to write centimeters. Don't forget your units. All right, so now let's find the mode. The mode is the number that appears the most. Now in this case, something new is happening. So let's go ahead and find the mode together. In this case, we see 191 centimeters appears twice, but 188 also appears twice. So in this case, the mode is actually going to be 2 numbers. So what you do is you write 188, comma, 191. Actually, we need to put the units for both those. 188 centimeters and 191 centimeters. So those numbers are both the mode of the data. So now we're done with the measures of the center of the data. In that case, you can see that this didn't really represent the center of the data that well. Again, sometimes these numbers make sense, sometimes they don't. But these numbers, the mean and the median, they actually did represent the center of this data pretty well. So again, sometimes statistics work, sometimes it doesn't. You have to make sure you're interpreting the data correctly. All right, so now let's find the range of the data. Remember, to find the range, you take the biggest number and subtract the smallest number. So go ahead and do that. When you come back, we'll do it together. All right, we're back. The range is equal to 202 minus 188. So if you do that over here, 202 minus 188, we cannot subtract 8 from 2, so we have to borrow from the 0. All right, but we cannot borrow from the 0 because the 0 has nothing. So we have to borrow from this 2 and make that a 1. We give the 1 that we borrowed from the 2 to the 0, and it becomes 10. Then we borrow from the 10, it becomes 9, and the 1 we took from the 10 we give to the 2, and it becomes 12. 12 minus 8 is 4. So this is all review. So don't complain if that seems complicated because, again, this is review. You've already seen this. If you're a little rusty on it, that's okay. But you should recognize this because unless you didn't do the homework. So 9 minus 8 is 1, 1 minus 1 is 0. So 14 is the range, 14 centimeters. All right, now we have to find the interquartile range. This is the range of all the numbers, but we want to find the range of just the middle numbers. So to do that, we have to find Q1. Q1 is the median of the first half of the data. So this is gonna take a little work, because when you have an odd number of numbers, you just ignore this middle number here. So you just consider this to be the first half of the data and this to be the second half. So let's look at the first half of the data. That's these numbers here. Find the median of the first half of the data. Well, the median is just the middle number of this first half, but again, there's only two numbers, so there is no middle number. So what we have to do is we have to use the mean to find the middle number, because the mean is going to give you the number right between those. So what you do is you add, to find the mean of these two numbers, you add the numbers up and then divide by 2. But if you do that, you're just going to get 188, because that's the middle of the numbers, obviously. And Q3, now I'm not going to rectangle that answer because we're not, the instructions don't tell us to find Q1 and Q3. It just tells us to find the interquartile range. So we're just going to find Q1 and Q3 to help us find the interquartile range. So the third quartile is the median of the second half of the data. So that's the middle numbers, but again, there is no middle numbers, so we have to find the mean of those two numbers. So 100, to find the mean, you add up the two numbers and divide by the number of numbers. So obviously there's two numbers, so 191 plus 202 is divided by 2. So let's do that. 191 plus 202, that would be 393, and then divide that by 2. So I'm going to do that over here. And we have to keep going because we have a remainder, so we have to add a 0 over here in a decimal. And we get 196.5 centimeters. So that's quartile 3. So now we're going to use the first quartile and the third quartile to find the interquartile range. So that's the third quartile minus the first quartile. All right. So I don't really have time to do that, so I'm just going to do it in my head. 8.5 centimeters. I'm going to double check that. That looks right. So that's the interquartile range. So we pretty much calculated all those numbers. Actually, these calculations go with those numbers. So now we just have to make a dot plot and a box and whisker plot. So notice that in this problem, I found the first and third quartiles and the interquartile range, but you can do that on the next problem. The hardest part of these problems is finding the first and third quartiles and the interquartile range, especially when you have an odd number of numbers. So now we have to make a dot plot and a box and whisker plot. So let's see if you can make a dot plot, and when you come back, we'll do it together. Remember, you have to set the range. Or excuse me, you have to set the scale. All right, we're back. So let's make our graph here. Our smallest number is 188. So let's see here. I think I'm going to start with 185. And then we have 190, 195, and 200, and then 205. So I'm going up by 5 each time, and I think that should be a good scale. Remember, you set the scale. Your scale might not be the exact scale that I have here, but the most important thing is that these divisions are equally spaced. Doesn't have to be perfect, but it has to be somewhat equally spaced. In fact, I'm going to move this one over a little bit. That's kind of sloppy there. Again, it doesn't have to be perfect, just has to be fairly good. All right, now so let's put the dots. We have 2 188s, we have 2 191s, and then we have 1 202. So again, there's not really that much data here to give us anything useful. We only have 5 data points. But it looks like this is an outlier from the data that we have. So anyway, if you got that dot plot, something that looks like that, then good job. So now we just have to make a box and whisker plot. Remember, you put a vertical line on the biggest value, a vertical line on the smallest value, and find the median and the first quartile and third quartile to make your box and whisker plot. I think there's going to be something weird that happens on this box and whisker plot, so let's go ahead and do it together. So this is the smallest value, this is the biggest value. The median is 191, so the median is going to be here. Quartile 1 is going to be here also, and then quartile 3 is going to be 196, which is here, 196.5. So something strange is going to happen here. Watch this. We're going to draw the box for the inner 3, and then we're going to draw the whisker, and you can see that there is no whisker on this side. So that was something a little different there that happened. So don't worry about that. It's no big deal. There's just sometimes you can have only one whisker, or sometimes you can have no whiskers. That's fine. And again, the reason we had no whisker on this side is because the smallest value just happened to be Q1. All right, so let's go on to number 2. Now we're going to do lifespans of houseflies. You may be surprised to find that houseflies, the flies that land in your food at home, they usually only live for about 24 days, 25, 26 days. So let's find the numbers. Go ahead and find the mean. And when you're done, we'll come back and do it together. All right, we're back. The mean is the sum of all the numbers. So I'll go ahead and double check, make sure you have those correct. And then you divide by how many numbers there are. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers this time. So we're going to divide by 8. So we have to add all those numbers up, line them up vertically. And you shouldn't be writing as sloppy as I'm writing now. I'm just trying to speed up here. So add those numbers up. And you should get, I got 205. So 205 divided by 8. So we're going to have to use the long division algorithm for that. So 205 divided by 8. 8 does not go into 20, or 8 does not go into 2, but it does go into 20. We have remainders, so we have to add a decimal and a 0, bring it down. 8 goes in 6 times. And look, bring down 0, we go in 2 times. 16, bring down the 4. And now we have 25.625. So I'm going to move that over. So if you got 25.625 days, good job. And remember to put your days there, that's your unit. So that's the mean. So now let's find the median. And remember, you cannot find the median unless you first order the numbers from least to greatest. Go ahead and try to find the median. And when you come back, we'll do it together. All right, we're back. The smallest number is 24. Then we have 3 25s. And then we have 3 26s. And we have a 28. And I think that's it. And that should be it. All right, so to find the middle number, we block out pairs. And you can see, because it's an even number of numbers, 8 numbers, there is no middle number. So you have to use the mean to find the. Get another color there. You have to use the mean to find the median. You have to find the mean of these two numbers. So add them up and divide by 2. And when you do that, you're just going to get a number right in the middle. So that's going to be 25.5. I'm not going to do that because we're running out of time here. So the median, I'll just put it up here. The median is equal to 25.5 days. Don't write as sloppy as I'm writing now. All right, so that's the median. Now we're going to find the mode. So at this point, you should have a pretty good idea of how to find the mode. So go ahead and find the mode, and when you come back, we'll do it together. All right, we're back. The number that appears the most is, actually we have 2 numbers that appear the most. We have 25 that appears 3 times, and we have 26 that appears 3 times. Just remember to put your units, which is days, which I almost forgot to do as I was writing it. So 25 days and 26 days, that's the mode. So there's 2 numbers for the mode. All right, so now we're going to find the range. Go ahead and find the range, and when you come back, we'll do it together. All right, we're back. The range is the biggest number minus the smallest number. So the range is 4 days. And you can do that on paper if you want, but really that's something you could probably do in your head. 28 minus 24. 4 days is the range. So as you can see, the range is quite small. Most flies die within, a range of 4 days from each other. In comparison to the other data. Now we have to find the inner quartile range. To do that, we have to find Q1 and Q3. Q1 is the median of the first half of the data. So the median is the middle number. But as you can see, because we have an even number of numbers, there is no middle number of the first half. Because there's 4 numbers in the first half, so there is no middle in 4 numbers. So what you have to do, again, you have to use the mean. You have to find the mean of these 2 numbers. If you add 25 up and divide by 2, because there's 2 numbers that you're trying to find the mean of, 25 plus 25 is 50, divided by 2 is 25, so it's just going to be 25 days. Now we're going to do the same thing with the 26s here, because this is the second half of the data. The middle is somewhere here. We have to find the mean of these 2 numbers, add them up, divide by 2, and you get just 26 days. You can do that if you want, but when these numbers are the same, if you find the mean of the 2 numbers, it's just going to be the number itself. So now we're going to use the first and third quartile to find the inner quartile range. That's what the problem is actually asking for. It's not asking for Q1 or Q3. So that's just going to be 26 minus 25 equals 1 day. So that's the inner quartile range. Again, the inner quartile range is much smaller than the overall range, because the inner quartile range doesn't consider those outliers. All right, so good job. Now we're going to find, I think I forgot to let you find the interquartile range on that one, so I don't know why, but I keep forgetting to let you do that last part. Now find a dot plot of the data. You should have an idea how to do that now, and when you come back, we'll do it together. All right, we're back. So let's figure out a scale. The smallest number is 24, and we're going to go to 28, so I'm just going to make intervals of 1. And let's make our dots. So we have 124, we have 1, 2, 3 25s, and 1, 2, 3 26s. And we have 128. So that's the distribution of the data. And we're going to have to shrink this because we're running out of room. So if you got that distribution there, that graph, good job. Now we're going to do a box and whisker plot. So go ahead and do that, and when you come back, we'll do it together. All right, we're back. You make a vertical line on the smallest number, vertical line on the biggest number, and then you make a vertical line on the median. The median is, where's the median here? It's 25.5 days. So that's here. And then quartile 1 is 25 and quartile 3 is 26. So you make your box with the middle 3 lines, and then your whiskers with the outer 2 lines. That was kind of a weird box there, sorry about that. So if that's what your box and whisker plot look like, then good job. All right, so now let's go to the next problem. Calories and hamburgers. So a calorie is just a measure of the energy that you're consuming when you eat a hamburger. So now we have 4 numbers. Go ahead and find the mean, and when you come back, we'll do it together. All right, we're back. The mean is the sum of all the numbers divided by the number of numbers, which is 4. All right, so we're going to go ahead and add up all those numbers, line them up vertically. Make sure we wrote those down correctly. And I get 26. I get 32. And I get 16. So I got 1,626. All right, so now we have to use the long division algorithm for that. That's the easiest way to do it. 4 goes into 1 no times, but 4 goes into 16 4 times. So we put the 4 above the last digit of the number we divided into. 4 times 4 is 16. Remainder 0. We bring down the 2, and after we bring down the 2, 4 still doesn't go in. So we have to put a 0. Then we bring down the next number. 4 goes into 26 6 times. 4 times 6 is 24. Remainder 2. Bring down a 0. 4 goes into 25 times. And the reason we had to bring down a 0 and add a decimal is because we still have a remainder. You still have to keep going. So bring the decimal straight up, and we have 406.5. So that's the mean. So if you got 406.5, good job. 406.5 calories, and you want to put a capital C because when you hear calories, a calorie, when you hear people use that word calorie in the real world, it's actually technically a kilocalorie. So you have to put a capital C there, but who cares about that? That's not important. All right, so if you found 406.5, good job. Now let's find the median. Go ahead and find the median. When you come back, we'll do it together. All right, we're back. We cannot find the median unless we first order the numbers from least to greatest. All right, so now the median is the middle number, but as you can see, there is no middle number because there's 4 numbers. So we have to find the mean of the 2 center numbers. So if you add those up and divide by 2, you're just going to get 398.5. It's not really that difficult to figure it out because it's just halfway between these two. So if you're just going to add a 0.5 to 398.5. But if you don't get that, then you can just add those up and divide by 2. So that's the median. And we have to put calories with a capital C. Now let's find the mode. See if you can find the mode, and when you come back, we'll do it together. All right, we're back. There is no mode. If you said none, good job. There's no mode. All right, now let's find the range. Go ahead and find the range, and when you come back, we'll do it together. All right, we're back. The range is equal to the biggest number minus the smallest number. And you can do that if you want, but I'm just going to do it in my head because we're running out of time. I got 59 calories. So if you got 59, good job. All right, now let's find the interquartile range. We can't find the interquartile range unless we find Q1 and Q3. Q1 is the median of the first half of the data, but the median is the middle number. There is no middle number, so we have to find the mean of these 2 numbers. To do that, you just add them up. 385 plus 398. Add them up and then you divide by 2. So 783. Then you take that number, 783, and divide by 2. Bring the decimal straight up and you get 391.5. So we need to do some calculations there to find Q1. We have to do some calculations to find Q3 also. A lot of calculations in this class. So we have to add up these 2 numbers and divide by 2. Again, because the median, we're trying to find the median of the second half of the data. But the median is the middle number. There is no middle number, so we have to find the mean of those two numbers. So that's 399 plus 444. And we get 843. Then we have to divide by 2. And we get 421.5. All right, so now we have to find the interquartile range, and this time I'm going to let you do it. In the previous problems, I forgot to let you do it. So the interquartile range, how do we find that? Go ahead and do that one, and when you come back, we'll do it together. All right, we're back. The interquartile range is the third quartile, which we just found, minus the first quartile, which we just found. So you can go ahead and do that over here. Subtract. We cannot subtract 9 from 2, so we have to borrow from the 4. Give the 1 to the 2, it becomes 12. 12 minus 9 is 3. Bring down the decimal, and you can see that the interquartile range is 30 calories. So that's pretty much it for the numbers. Now we just have to graph it. So go ahead and make a dot plot, and when you come back, oh, by the way, if you got 30, good job. Make a dot plot, and when you come back, we'll do it together. All right, we're back. Whoops, sorry about that. I told you to make a dot plot, and then I didn't show you the data there. So let's see. We have to start at 385 and go all the way to 444. So I'm going to go up by 10. All right, that should be enough there. Move that over a little bit. 385, 95. Seems right. Let's make our dots. So there's 1 385, 1 398, which would be about there, I believe. 1 399, which would be about there, and a 444, which would be about there. So if that's what you got for the dot plot, good job. So now we're going to do a box and whisker plot. Go ahead and do that. When you come back, we'll do it together. All right, we're back. So put a vertical line on the smallest number, a vertical line on the biggest number, and a vertical line on the median, which is 398.5. 398.5. I think that would be about here. Again, it doesn't have to be exact. Then put a vertical line on Q1, which is 391.5. That's about over here. And then Q3, put a vertical line, 421. That would be about here. And then make your box for the inner 3 lines. I got to make that box a little better. Make your box. That was even worse. Sorry. And then your whiskers. So if that's your box plot, if that's kind of what you got there, good job. All right. So now we're going to find the clock speed of, or we're going to study the clock speed of computer processors. The clock speed is just how fast the processor goes. And these speeds are measured in gigahertz. If you buy a computer, you'll see something like GHz. That's just the abbreviation for gigahertz. So go ahead and find the mean of this data set, and when you come back, we'll do it together. All right, we're back. So the mean is equal to the sum of all the numbers divided by the number of numbers. And how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by 9. Now we have to add all these numbers up. So now we just have to figure out where to put the decimal. The decimal goes straight down, so right there. So we have 34.3 divided by 9. We have to use the long division algorithm. And it's just going to keep going on and on. 1, 1, 1, 1. So you have to bring the decimal straight up. It goes right there. So the mean is equal to 3.81 bar. But we're just going to round off. Actually, we can just keep the bar there. All right, so, and that's gigahertz. Gigahertz is represented with a capital G, capital H, and a lowercase z. So if you couldn't put the units because you didn't know what they were, that's okay. Let's go ahead and shrink this stuff. That's a lot of math there. So if you got 3.81 bar for the mean, good job. All right, now let's find the median. So the median is the middle of the data, but we cannot find the median unless we order the numbers from least to greatest. So go ahead and do that, and when you come back, we'll do it together. All right, we're back. The smallest value is going to be, I believe, 3.5. Then we have 3.6. Then we have two 3.7s. And I'm going to go ahead and mark out these numbers as I find them, because there's a lot of numbers to keep track of here. All right, then we have we have many 3.9s. We have three 3.9s. 1, 2, 3. So now we have to find the middle numbers. So we'll block out one pair, and then a second pair, and a third pair. And thank goodness, when we block out the fourth pair, you can see there's a middle number. So the median is going to be really easy for this one. So if you got 3.9 gigahertz, good job. All right, so now we're going to find the mode. Go ahead and find the mode, and when you come back, we'll do it together. All right, we're back. 3.9 appears 3 times, which is more than any other number, so the mode is going to be 3.9 gigahertz. So if you got 3.9 gigahertz, good job. All right, so now let's find the range. Go ahead and find the range, and when you come back, we'll do it together. All right, we're back. So the range is the biggest value, 4.1, minus the smallest value, which is 3.5. And that's just going to be 0.6 gigahertz. I just did that in my head, but you can do it on paper if you want. I did it in my head because we're starting to run out of time. So if you got 0.6 gigahertz, good job. Now let's find the interquartile range. We can't do that unless we first find Q1 and then Q3. So Q1 is the median of the first half of the data. So the first half of the data is here. We have an odd number of numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers. So that means we just ignore this middle number, and we consider this to be the first half of the data. And the median of the first half of the data is the middle of the first half of the data. But the problem is there is no middle. So we have to find the mean of these two inner numbers. So we just add them up and divide by 2, because that's how you find the mean. You take the numbers, add them up, and divide by the number of numbers. There's 2 numbers in the middle of the first half of the data. So you just add them up and divide by 2. And when you do that, you're going to get 3.65. And when you find the median of the second half of the data, you're just going to get 3.95. We don't really have time to do all the calculations, but I think you get the point. And we need gigahertz for both of those. All right, now it's time for you to find the interquartile range. So go ahead and, now that we found Q1 and Q3, I don't know if I allowed you to find Q1 and Q3 and all the other problems. I'm sorry about that. For some reason, I keep rushing ahead when I get to Q1 and Q3. But hopefully you're getting the idea of how to find those first and third quartiles. So now you find the interquartile range. All right, interquartile range is the third quartile minus the first quartile. And if you do that, you're going to get 0.3 gigahertz. So if you got 0.3 gigahertz, good job. All right, so now all we have to do is make a dot plot. So go ahead and make a dot plot of the data, and when you come back, we'll do it together. All right, we're back. So let's draw our graph here. And smallest value is 3.5. And we're going to go up to 4.1, so I'm just going to go 3.5, 3.6, 3.7, 3.8, 3.9, 4, and 4.1. That should be good enough. All right, so let's make our dots. 3.5. Got 1 dot, 2 dots. 1 dot, 1 dot, 2 dots. 3 dots on 3.9. So there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. It's always good to go back and count the number to make sure that you didn't miss any or put an extra one there. So I'm going to shrink that a little bit. So that should be your dot plot. Looks something like that. Let me double check that here. I think that's correct. All right, now we're going to make our box and whisker plot, so go ahead and try that. And when you come back, we'll do it together. All right, we're back. So vertical lines on the biggest value and smallest value. Vertical line on the median. 3.9 is the median. We're having to write small here. Vertical line on Q3 and Q1. 3.95 is about there. 3.65 is about there. So then draw your box. Sorry, it's kind of cramped here. And there you go. That's your box plot. So if you got something similar to that, good job. You should never write this sloppy when you're actually doing an academic paper. I'm just doing this because I'm running out of room and I'm running out of time. All right. Let's see here. So we're going to do one more of these, and then we'll go on to bar graphs and line graphs. You should be getting the hang of this. So let's do this, find the mean, and when you come back, we'll do it together. All right, we're back. The mean is equal to 12, the sum of the numbers, 1200 plus 1200 plus 1200, so on and so forth. All divided by how many numbers are there? There are 1, 2, 3, 4, 5, 6 numbers. So divided by 6 numbers. So we'll go ahead and add all those up. And I got 6,800. And then you're going to divide that by 6. So we're going to use the long division algorithm. 6 goes into 6 one time, so on and so forth. And it looks like we're just going to keep going on and on here. Bring the decimal straight up. And we're going to get 1,133.3 bar. So if you got 1,133.3 bar dollars, good job. Now I didn't mention here that a dollar sign usually goes to the left of the number. So you can go ahead and put that dollar sign there. But if you got that number, good job. All right, so we're going to have to shrink this. Now find the median, and when you come back, we'll do it together. All right, we're back. we cannot find the median unless we first order the numbers from least to greatest. Trying to save room here. All right, so now let's find the middle number. Unfortunately, there is no middle number. If you try to block out those pairs, you see that you're left with two numbers in the middle, so there is no middle. So you just have to find the mean of these two middle numbers. And when you do that, I'm going to go ahead and do that in my head. So add those numbers up, divide by 2, and you should get $11.75 dollars. Then we're going to have to move that over and put dollars. $11.75 or 1,175. So if you got 1,175, good job. Now let's find the mode. Go ahead and do that, and when you're done, we'll come back and do it together. All right, we're back. The mode is 1200 because 1200 appears more than any other number. So if you got 1200, good job. Now let's find the range. Go ahead and find the range, and when you come back, we'll do it together. All right, we're back. The range is the biggest value, which is 1200, minus the smallest value, which is 1000, and you can pretty much just do that in your head. It's going to be $200. That's the range. So if you got $200, good job. Now let's find the interquartile range. We can't find the interquartile range unless we first find the quartiles. The first quartile is the median of the first half of the data. So we got to look over here with our numbers ordered. We can't find the quartiles unless we order the numbers from least to greatest. This is the first half of the data. And the median of the first half is the middle number of the first half, so that's obviously just 1,050. So this time the first quartile was really easy to find. 1,050. So see if you can find the third quartile, which is the median of the second half of the data. All right, we're back. So the median of the second half of the data is the middle of the second half, which is 1,200. All right, so now we want to find the interquartile range. Don't rectangle the Q1 and Q3 because that's not what we're being asked to find. We're just going to use those numbers to find the interquartile range. So find the interquartile range, and when you're done, we'll come back and do it together. All right, we're back. So the interquartile range is Q3 minus Q1, and you can do that if you want, but it's just going to end up being 150. 150, and again, you want to show all your work here, but I'm just rushing ahead because I don't want to keep you too long here. $150. So now we're going to do the dot plot. Go ahead and draw your dot plot, and when you come back, we'll do it together. All right, we're back. Let's start with 1,000, then 1,050. We'll go up by 50s here. 1,100, 1,150, and then 1,200. That should be a good distribution there. So we have 1,000, 1,050, 1,150, and we have 1, 2, 3 1,200s. So it's kind of an odd distribution, but it's a distribution nonetheless. So if you got that dot plot, good job. I'm going to shrink that a little bit. All right, now draw a box and whisker plot, and when you're done, we'll come back and do it together. All right, we're back. So vertical line on the smallest value, vertical line on the biggest value, vertical line on the median. The median was 1175, which is about there. And the Q1, vertical line on Q1, vertical line on Q2, or excuse me, Q3. So Q3 is there. So this is an example of a box and whisker plot where the whisker on the right is cut off. There is no whisker on the right. Because the biggest value is also the third quartile. So let me just double check that. Everything looks right. So if you got that box and whisker plot, good job. All right, so we don't have time to do numbers 6 and 7. So we're just going to go ahead and go on to our bar graphs and our line graphs. Bar graphs and line graphs are going to be really easy. Bar graphs are used for what you call categorical data. So this is data that you categorize. Favorite food of children in a 6th grade classroom. So we've already done dot plots. That's a type of graph. Box and whisker plots are types of graphs. But we're going to learn bar graphs and line graphs today. And then when we're done with that, we'll be done with this class. So this is categorical data because you have 10 kids that like pizza. That's their favorite food. And then you have 7 kids that like tacos the most. That's their favorite food. And so the kids are categorized in terms of what their favorite pizza is. So this is called categorical data. So you use a bar graph for categorical data. You're going to see what we mean when we graph this. Let's make each blue line, we need to go to 10 as the biggest number. Again, we have to set the scale here. So let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess we don't have enough room for that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can just make a small graph, I guess. 2, 4, 6, 8, 10. And here we have pizza and tacos and hamburgers and fish. The first row almost always goes on the what you call the horizontal axis. This is the vertical axis and this is the horizontal axis. Now we have to label our axes. So on the bottom we have types of food. So we can just say food, and on this axis it's number of children. All right, so there's 10 children that like pizza, so we're going to make a big old bar for those kids. And then we have 7 kids like tacos. That's their favorite food, so we're going to make a big old bar for those kids. And the widths of these bars have to be equal, because if they're not equal, then they're going to look strange. And there's 4 kids that like hamburgers the best. And there's 1 kid that likes fish. So that is a bar graph, and it's used for categorical data. And you can color these in if you want, but we don't really have time for that. So we can see the distribution of this categorical data. Just by looking at this, we can see that most kids in the class like pizza, or more kids in the class like pizza than any other type of food. And then the second in place is tacos, and third is hamburgers, and so on and so forth. And we can see immediately that not many kids like fish in this particular class. Now there's one more thing that we have to do. And by the way, if you don't label your axes, you're going to get points taken off in any classroom. Teachers they just absolutely love to take off points for not labeling your axes. And there's one more thing that teachers love to do. They love to take off points if you don't label the graph. We have to title the graph favorite food of children in a 6th grade classroom. We're kind of out of time, or we're running low on time, so I'm just going to leave it as favorite food of children. All right, so why don't you try number 9? Go ahead and make a bar graph of that data, and when you come back, we'll do it together. All right, we're back. So the biggest number is 7, so 1, 2, 3, 4, 5, 6, 7. I'm just going to make the blue lines equal to 1. And by the way, I should have made marks here. I forgot to do that. 1, 2, 3, 4, 5, 6, 7. And we've got blue, green, so on and so forth. All right, so 7 kids like blue. 1 kid likes green. 4 kids like red. So on and so forth. So you just fill these in. Nobody likes orange. And there you go. So you can see the distribution of this categorical data just by looking at that graph. So if you got that graph, good job, but you're not done yet. You would get points taken off unless we label the axes. We'll label that axis colors, and we'll label this axis number of children. And we have to title the graph, so favorite color, and I'm just going to give it a short title because we don't have time. All right, so if you got that graph and you got all your labels, again, you're going to get points taken off if you don't have a title for the overall graph and also titles for the axes. You must have those titles for full credit. All right, so now let's try another one of those. We'll try one more of those bar graphs, and then we'll go to line graphs, and after line graphs we'll be done for the day. So let's see. Go ahead and make a bar graph of number 10, and when you come back we'll do it together. All right, we're back. So we need 80 as the highest number. So let's see, 10, 20, 30, 40, 50, 60, 70, 80. So I'll make each blue line 10. And then we have a rating of poor, good, and excellent. So we're going to label this ratings, this axis ratings, and this is again, number of people. So all of our data just happens to be mostly people that we're counting here, but you can count other things also. All right, so also let's go ahead and write the bars. So 16 say poor, 16 didn't like the movie, 52 liked the movie, and 80 really liked the movie. They said it was excellent. And we just need one more thing. We need a title. Movie ratings. If you didn't write a title, and if you didn't title your axes, you would get points taken off. So if you got that bar graph, good job. So again, those are bar graphs. They're used for categorical data, when each person is categorized into a particular column here. Now, one more type of graph that we're going to learn is line graphs. Let's do this first one to show you what line graphs are. So we're going to draw a vertical axis and a horizontal axis like usual. And we're going to label the months. This is rainfall over the course of a year. this over. So we have all the months of the year. All right, and then we're going to have rainfall in inches. The biggest number is, let's see, it looks like the biggest number is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need to move this down, or maybe we can shrink it. Move it down for now, and then we'll shrink it later. I'll make this line a little straighter there. Try to be neat, unlike me at this point. All right, so rainfall in inches, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 inches. That's the biggest. And we write inches. So May, there's nothing. June, there's nothing. July, there's 0.1. So what we're going to do is write dots. Got a big old dot there. August is 0. September is 0.5. So we put a big old dot there. October is 1 inch. November is 4. So we're just putting dots. It's kind of like the dot plot that we did. Similar to that. 8.5 is there. And 11 is here in January, because that's when it rains the most. In wintertime, February is 2 inches, and then all of a sudden it goes way down to 2 inches in February, 1.3 in March, and 0.8 in April. So as you can see, it was like a dot plot. But now, because we're going to make this a line graph, we're going to connect the dots. So we're going to make lines, straight lines, to connect these dots. And there you go. So this data could be considered categorical because you're categorizing the rainfall into each month. But it can also be considered what's called continuous data because the rainfall kind of just falls continually throughout a certain amount of time. Usually line graphs are used when something's happening over a certain amount of time. So on the homework, I have some problems where you're asked to figure out if you can use a bar graph or a line graph, and in order to do that, you have to figure out if it's categorical or continuous. So I'll ask you which graph would be best to use. We didn't really talk about that much, but just try your best on that. So as you can see, the rain changes like so as we go throughout the year. It spikes during the winter time, and there's almost no rain during the summer months. So that is a line graph, but I did not label the, I have to shrink this thing so I can label the horizontal axis. Horizontal axis is month, and we have to label it rainfall. Now, of course, if this were an actual graph, you'd have to say rainfall where? Where's the rainfall? Is it rainfall in California? Is it rainfall in Cincinnati? You know, where's the rainfall? But we don't really have time for specific titles. So there you go. It's pretty easy. You just make the dots, and you connect the dots. So why don't you try number 13, and when you come back, we'll do it together. All right, we're back. We're going to make a graph here, a line graph. So the sales go up to 90. So let's try 10, 20, 30, 40, 50, 60, 70, 80, 90. So that'll work. And this is in millions. So that's millions in dollars. And down here we have the years, 2012, 2013. So again, we have time on the horizontal axis. Whenever you have time, a line graph is usually the best graph to use. All right, so we're going to make a dot for $23 million. And 50 million. 2014 we have 61 million. 2015 we have 90 million. Then you're going to connect the dots. And there you go. I may put these two a little too close together, but so now we're going to label this year down here. You have to label the axes and then title it electric car sales. So again, you need all your titles. You need the title of the overall graph, and then you need the title of the axes. So that's pretty much it for this class. I have some more problems, but it's just really the same thing. As you can see, line graphs are really not that difficult. You just got to remember to do your titles. And bar graphs, you can see, are not that difficult either. So that's it for this class. Here's the homework. You can take a screenshot of that if you want. I have the actual homework, which is the first 2 pages, and then I have the answers to the homework in the second 2 pages. So get a screenshot of this. That's the homework, and a screenshot of the answers for the homework. So that's it for this class, and I'll look forward to seeing you in class 29.